Hi friends, you are welcome to your favorite learning channel. Today we are going to discuss about chemical reactions and balancing of chemical equation. In today's class, I will give you logic on how to write chemical reactions and balance chemical equation. So at the end of this lesson, you will be able to write chemical reaction and balance chemical equation. You are not yet a science student if you don't know how to write a chemical reaction and you cannot balance what? A chemical equation. So let's begin. Let's first define chemical reaction. What is chemical reaction? This is the process whereby one or more substances are converted to one or more new products or new properties. It's the process whereby one or more substances are converted to one or more new products. So reaction between A and B will give us AB. So AB is the product formed. AB is the product formed. So the product form is totally different from the reactant. The product form is totally different from the what? From what we have at the reactant side. So in a chemical reaction, the left hand side is called what? Reactant side. The left hand side is called reactant side, while the right hand side is called the product side. The product side. The product side. Then what are those things that you need to know before you can write a chemical reaction and balance chemical equation? The first one is chemical symbol. You must be able to write the chemical symbols of different elements. So let's start from element number 1, which is hydrogen. The chemical symbol of hydrogen is what? Is capital letter H. Then the chemical symbol of lithium, which is the third element, is Li. The chemical symbol of the second element, helium, is what? Is He. Then that of nitrogen is N. The chemical symbol for oxygen is what? Is O. So you must be able to write chemical symbols of different elements. Then number 2 is you must be able to identify or indicate the atomicity of what? Of each element involved during the chemical reaction. Then we have 4 classes of atomicity. Number 1 is monoatomic. So all atoms of noble gases are monoatomic. The example of atom of a noble gas is helium. So helium is what? Is a monoatomic. That mono means one, but the subscript 1 is usually omitted. So we don't always put what? The subscript 1. So it is always written as what? As He. Then another one is argon. Argon is what? Is Ar. Argon is what? Is a noble gas. So all atoms of noble gases are monoatomic. Then all atoms of metal, that is all metallic atoms are also what? Monoatomic. Then example of what? Of a metal is sodium. So sodium is what? Is a monoatomic. We write sodium stand on its own during what? During chemical reaction. Then another metal is magnesium. Magnesium is what? Is a monoatomic because it is what? It is a metal. Copper is a metal. So copper is what? Is a monoatomic. All metallic atoms are monoatomic. Then we also have diatomic. That is, diatomic always go with what? Subscript 2. Diatomic. All atoms of halogen are diatomic. So all atoms of halogens are diatomic. Then what are halogens? Halogens are what? Are group 7 elements. So which means that all atoms of halogen, that is element under halogens, group 7 elements, are what? Are diatomic. So when you write diatomic elements during chemical reaction, you put what? Subscript 2. For example, chlorine is in group 7. So when you want to write chlorine during chemical reaction, you put 2 at the base. You put subscript 2. Then another one is fluorine. Fluorine is what? Is a halogen. So when you want to write fluorine during chemical reaction, you put 2 at the base. Iodine is what? Is a halogen, so you put 2 at the base. Bromine, so you put 2. So all these are what? Are halogens. Then oxygen. Oxygen is what? Is also what? Is a diatomic gas. So when you write oxygen during chemical reaction, you have to put what? Substrate 2. Then nitrogen is also what? Is a diatomic gas. So all these now are what? Are diatomic gas. So nitrogen is what? Is a diatomic gas. Diatomic gas. So all these elements are what? Are diatomic gases. They are diatomic. So when you write them, when you are using them during chemical reaction, you put what? Substrate 2. Then hydrogen 2. Hydrogen is what? Is a diatomic gas. So you put substrate 2 when you are using them during what? Chemical reaction. Then we also have triatomic gas. Triatomic gas. Ozone is what? Ozone, which is O3. Ozone is what? Is a triatomic gas. Ozone is a triatomic gas. Then we also have polyatomic gas. Polyatomic gas. Then polyatomic gas. I mean polyatomic, sorry. The polyatomic, e.g. phosphorus is what? Is a polyatomic. So we have phosphorus 4. Then we have what? Phosphorus 5. So phosphorus is what? Is a polyatomic. Then the next thing is what? The valence. Or you call this what? Valence electron. So you also need valence during what? Chemical reaction. So what is valence electron? Valence electron. Valence electron is the number of electrons that an atom loses or gains to become positively or negatively charged. Valence is the number of electrons that an atom loses or gains to become positively or negatively charged. Then the atom with positive charge are called cations. Cations. So the cations are what? Are those elements, are those atoms that lose electron to become what? Positively charged. They are those they are the atoms with what? With positive charge. Then we also have an ion. Anion or anion. So we also have anion. So anions are what? Are negatively charged. Are negatively charged. So metallic atoms are cations. So metallic atoms are what? Are cations. While non-metallic atoms are what? Are anions. Are anions. So metallic atoms are cations, while non-metallic ions are what? While non-metallic ions are what? Are anions. And anions. Then how can we determine the number of what? Of valence electrons. So you write the electronic configuration of that element in ratio form. So let's take for example, how can we determine the metallic ions? How can you bring out the charge, that positive charge on them? For example, now sodium is the number 11. Sodium is the number 11. Then according to electronic distribution or electronic shell, the fourth shell, which is K shell, we carry the maximum of 2 electrons. Then L shell, we carry the maximum of what? Of 8 electrons. So if you want to write the electronic configuration of sodium in ratio form, so this 11 is the number of proton. So at the same time, when you are now sharing it on what? On electronic shell, you call this what? Electron. So the first shell, don't forget that the first shell, which is K shell, we carry the maximum of 2 electrons. Then out of what? Out of 11. Then the second shell we carry 8. So 2 plus 8, that is what? That is 10. So then the last one will now be 1. Then from the second shell upward, we are writing it in ratio form. After the first one will carry the maximum of 2, while others will carry the maximum of 8 electrons. So if you don't complete one, you don't move to the next shell. So it is only the first one that will carry what? 2 electrons. So the remaining shells will carry what? 8 electrons. So but instead of drawing those electronic shell, because if I want to do it in form of shell, I'll draw a circle. So this circle is representing what? Electronic shell. So the first shell with what? 2 electrons. So this star or dot is representing what? Is representing electron. So these are the 2 electrons. These 2 electrons. Then you draw another shell with 8 electrons. With 8 electrons. Then while the last one with what? With 1 electron. So this last electron is called what? Valence electron. So we call it electron at the outermost shell. So the valence electron is in what? Is the number of electron at the outermost shell. So now, this sodium atom to become an ion, it will become an ion with the number of what? Of valence electron. So the valence electron for this one is what? Is 1. So therefore it will be +1. So those elements with 1, 2 and 3 valence electron, they carry what? Positive. They are positively charged. Those elements with 1, 2 and 3 valence electron, they are positively charged. So this is what? +1. This one means plus, so it is +1. So I can write it as plus. So we always write it as plus, so we don't write it as +1. So let's take another element, magnesium. Let's take another element. Magnesium is in number 12. So magnesium is in number 12. So if I want to share the 12 electrons now on electronic shell, the first shell will carry 2. Then the second shell will carry 8. So out of 12, 2 plus 8, that is 10. So remainder 2. So the last shell will now carry 2. So the electronic configuration of magnesium in ratio form will be 2, 8, 2. So this last 2 is your valence electron. So to write magnesium as what? As an ion, it will now be Mg2+. Mg2+. Then don't forget that I said that those elements with 1, 2 and 3 electrons are positively charged. So those elements with 1, 2 and 3 electrons are positively charged. So let's take an element or an atom with 3 electrons, with 3 valence electrons. Then aluminium. Aluminium is in number 13. Then the first shell will carry 2. Don't forget that the first shell will not carry more than what? 2 electrons. Then the second shell will carry 8. So out of 13, 2 plus 8, that is 10. Remainder what? Remainder 3. So the last shell, which is what? Called valence electron, so we carry 3. So the valence electron for aluminium is what? Is 3. So aluminium ion, or the valence of what? Aluminium will now be 3+. So if I want to write aluminium ion, it will be Al3+. Al3+. So those elements with 1, 2 or 3 valence electron are positively charged. So all these are what? Are metallic atoms. So those elements with 1, 2 or 3 valence electron except hydrogen are positively charged. Those elements with 1, 2 or 3 valence electron except hydrogen are positively charged. So at the same time, they are what? They are metallic atoms. So let's move to non-metallic atoms. So let's move to non-metallic atoms. Example is oxygen. Oxygen. Oxygen is in number 8. When you count your elements, 1, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So oxygen is in number 8 in the periodic table. So write the electronic configuration of oxygen in ratio form. So it is having how many electrons now? Write it, distribute those electrons on electronic shell. So the first shell will carry 2 out of 8. So 2 minus 8 will give me 6. So remainder 6. Don't forget that from the second shell upward, we carry 8, maximum of 8 electrons. 8 electrons. So 2 ratio 6. Now you can see that this one, the last shell, this is our valence electron now. But this last shell, it needs how many to balance that 8? It needs 2 to balance that 8. So therefore, the charge on oxygen will be 2 minus, because it needs 2 to balance what? That 8. It needs 2 to balance that 8 electrons. So it's 2 minus. So now those elements with 5, 6, 7 electrons are negatively charged. Those elements with 5, 6, and 7 electrons are negatively charged, and at the same time they are non-metallic atoms. They are non-metallic atoms. So you calculate their valence electron, or the number of valence, by the remaining electron for them to balance that what? That 8 electrons, to balance the octet structure. Octet means 8. So let's take another one. Let's take another element. Nitrogen. Nitrogen. Nitrogen is in number what? Number 7. So let's write the electronic configuration of nitrogen in ratio form. Out of 7 electrons, the first shell will take 2. Then the second shell will now take 5. 2 plus 5 equal to 7. So you can see that this shell, this is the second shell, and the second shell is supposed to carry what? Maximum of 8 electrons. The second shell is supposed to carry maximum of 8 electrons. So it needs how many to balance that 8 electrons now? It needs 3. So therefore, if I want to write nitrogen ion, it will be 3 minus. It will be 3 minus. So you can't by the what? The number of electron for them to balance that what? 8 electron. That is to balance the octet. To balance octet. Octet means 8. So let's take another one. Let's take another one. Chlorine. Chlorine is in number 17. Chlorine is in number 17. So the first shell will carry 2. Then the second will carry 8. So out of 17, 2 plus 8, that is 10. So remainder what? Remainder 7. Remainder 7. Then like I said, that those elements with 5, 6, and 7 electrons are negatively charged. So you count their number of valence electron by the remaining electron for them to complete that octet structure. To complete that octet, that is to complete 8. So this one now, don't forget that the number of electron that's supposed to be here should be what? It should be 8. But this one is 7 now, so it needs one more to balance. So if I want to write chlorine ion, I will write it as Cl minus. Cl minus, because it needs one more to balance what? To balance the octet electron, that is the octet structure. So therefore, they are what? They are negatively charged. So the anions are negatively charged. So this one, the cations are what? Are positively charged. Are positively charged. So this one by the number of their valence electron. This one by the number of electrons to complete the octet structure. So you count the number, you determine the valence electron of the, or the number of valence by the what? By the number of electron, which is valence electron. This one, you determine their valence by the remaining electron to complete the what? To complete the octet structure. To complete the octet structure. So another one is radical. You must be able to identify radicals. You must be able to identify radicals. Then what are radicals? What are radicals? Radicals are a group of atoms. Radicals are group of atoms with two or more elements carrying positive or negative charge. Radicals are group of two or more atoms of different elements carrying what? Positive or negative charge. Then examples of radicals are examples of radicals are NH4 plus. NH4 plus is a radical. Then we call it what? Ammonium ion. Ammonium ion. It is an ion because it carries what? Positive charge. So an ion will carry either positive or negative charge. When it is carrying a what? A positive charge, you call it what? A cations. Then when it is carrying what? A negative charge, you call it what? Anions. Anions. You call it anions. So this is what? This is a radical because it contains what? Two atoms. So two atoms. So group of two or more atoms with positive or negative charge is called what? Radicals. Group of two or more atoms with positive or negative charge is called what? Is called radicals. Now, another example of radicals is what? OH. OH minus. Then I can explain how they derive this what? This plus or minus. So let me first write other examples. Another one is CO3, 2 minus. Then we have SO4, 2 minus. Then we have NO3 minus. Then we have HCO3 minus. So all these are what? Are common examples of radicals. Then I'm going to explain how they derive this positive and the negative, their charges. I want to explain how they derive their charges. So let's take the first one, NH4. Let's assume that we don't know the number of charge that is on NH4. So what is the valence electrons? How many elements do we have here? We have nitrogen, then we have hydrogen, 4 hydrogen, 1 nitrogen and 4 hydrogen. Then what is the valence what? Electron or the valence of nitrogen? Don't forget that nitrogen is the number what? Number 7. So that is 2:5. So it needs what? It needs 3 to balance. So it will be 3 minus. Then that of hydrogen. Hydrogen is the number 1. So the charge on hydrogen is plus because it carries what? It has only one valence electron, number 1. So the charge on hydrogen is 1, which is the same thing as plus 1. Which is the same thing as plus 1. So let's combine the charge here and the charge here together. So the charge on this one is what? Minus 3. So times 1 nitrogen, that is minus 3. So the charge on this one is plus 1. So plus 1 times 4 hydrogen will give us plus 4. So minus 3 plus 4. Minus 3 plus 4 will give us plus 1. So that is how they derive plus 1 on this NH4. That is how they derive plus 1. So let's look at that of hydroxy ion. We call OH. OH is called what? Hydroxy ion. OH minus is called an hydroxy ion. How did they derive this minus? How did they derive this minus? So let's look at the way I'm going to do it. Then oxygen. We have oxygen and hydrogen. Oxygen is in number 8. So what is the valence, the number of valence for oxygen? So the first shell will carry 2 out of 8 electrons. Then the second shell will carry 6. 2 plus 8, that is 6. So the second shell now, it needs what? 2 more. It needs 2 electrons to balance. So therefore, the charge on oxygen will be 2 minus. Then hydrogen is in number 1. Number 1. So the charge will be plus 1, which is the same thing as plus. Now, let's combine the what? the charges together. So let's combine their charges together. So oxygen is -2 times 1 oxygen, that's -2. Hydrogen is what? +1. So +1 times 1 hydrogen, that is +1. So -2 plus 1 will give us -1. So -1 is the same thing as minus. That is how they derive what? Minus for this one. That is how they derive minus. Now let's move to CO32 minus. CO32 minus. CO3. So we don't know the number of what? We don't know the number of charge on CO3. So let's derive the charge on CO3. Carbon is the number 6. We have carbon, we have oxygen. We have carbon, we have oxygen. So carbon is the number 6. So the electronic configuration in ratio form will be 2:4. So those elements with 4 electrons, with 4 valence electron are what? Are usually positive. So they are positively what? Charged. So the charge on carbon is what? +4. Is +4. So therefore, the charge on oxygen is in number 8. So that is 2:6. So it needs 2 more to balance. So the charge will be 2 minus. So now let's combine the two charges together. Let's combine them together. Then carbon is what? We have 1 carbon. So 1 times +4 will give us +4. Then oxygen is 2 minus. -2 times 3 will give me -6. So +4 minus 6 will give me -2. So that is how they derive 2 minus. That is how they derive these 2 minus. Now let's move to SO4. Then this CO3 is called triazocarbonate what? Triazocarbonate 4. Then let's move to SO42 minus. SO42 minus. Then if you look at S is negative, then oxygen 2. Forget about these two, the charge, that is 2 minus. So sulfur is in number 16, oxygen is in number 8. So if you want to write the electronic configuration of this sulfur, that would be 2:8, then /6. 2, 8, 6 will give us 16. Then the electronic configuration of this one will be 2:6. 2 plus 6 will give us 8. Then the charge on this one needs what? 2 what? It needs 2 more to balance. So the charge on oxygen will be 2 minus. Then if you look at this one too needs what? 2 more to balance. So this one too will be 2 minus. This minus, negative will repel. Positive and negative will what? Will attract. So which means that it is only positive and negative that can attract. So therefore we assume that this one is what? Is positive. Because negative will repel and positive will what? Will attract. So since the two are negative, so we assume that the first one is what? Is positive. So we assume that the first one is positive. Then we now leave the second one as what? As negative. Then don't forget that the positively charged ion, we always use the number of electrons at the outermost shell. The positively charged ion, we use their what? The number they carry what? They carry that charge with the number of electrons at the outermost shell. So the number of electrons at the outermost shell of sulfur is what? 6. So when we assume that it is positive, it will be +6. Now, let's combine the what? The charges. Let's combine their charges together. Now, how many sulfur do we have? We have 4 here. How many sulfur do we have? We have 1. So +6 times 1 will give us +6. Then oxygen is -2 times 4 will give me -8. So +6 minus 8 will give me -2. So the charge on SO4 is what? Is 2 minus. So you can try that of NO3 and HCO3 at the end of the class. So try it yourself. Then Another one, another thing I would like to tell you about radicals is we don't always separate radicals. We don't always separate radicals during chemical reaction, except a gas is evolved from the radical. We don't always separate radical during chemical reaction, except a gas is evolved during the what? The chemical reaction. So take note of that. Then let's move to, so let's begin with different chemical reaction and balancing of chemical equation. So to write any chemical reaction and balance any chemical equation, the following steps that I've explained must be understood, must be well understood. And you must follow what? You must follow them in order. You must follow the following steps in order. So I'm going to group chemical reaction into three. I'm going to group writing of chemical reaction into three stages. So the first stage is reaction between two atoms of different elements So let's begin with two atoms of different elements. So for example, example 1, reaction between sodium and chlorine will give us what? Now, before we react sodium and chlorine to form a product, so don't forget that the next step after what? After symbol is what? Is atomicity. So let's assign their atomicity. Let's identify the atom. So the atomicity of sodium is 1, because sodium is what? Is a monoatomic, is a metal. So all metallic atoms are monoatomic. Then chlorine is what? Is a diatomic. So we add subscript what? 2. We add subscript 2. So how are we going to form our product now? So let's follow me. Then the first one, which is sodium. What is the charge on sodium? What is the charge on sodium? I've explained that under what? Valence electrons. So the valence electron of sodium will be the charge of what? On sodium. Then sodium is in number 11. Sodium is in number 11. The first shell we carry 2. The second we carry 8. The third one we carry 1. 2 plus 8 plus 1 will give us what? 11. And like I said, that those elements with 1, 2 and 3 electrons are what? Are positively charged. So this one is having what? Valence electron of 1. So the charge on sodium will be plus, which is the same thing as what? Plus 1. Which is the same thing as plus 1. Then chlorine. What is the charge on chlorine? Chlorine is in number 17. So the first shell we carry 2. The second we carry 8. The third one we carry 7. So 2 plus 8 plus 7 equal to what? Equal to 17. So chlorine needs what? It needs 1 more electron to balance this octet. So therefore the charge on chlorine is what? Is 1. Like I said, that those elements with 5, 6, 7 electrons are negatively charged. So you calculate the number of their valence electron, the number of valence by the what? By the remaining electron for them to balance their outermost shell. So by the remaining number of electrons to balance their outermost shell. So the charge on chlorine is what? Is minus 1. Then you combine the two charges. Then positive we combine with negative. So you combine the two charges to neutralize each other. So the two charges must neutralize each other. So the charge on this one is plus 1. So plus 1 times 1 sodium, because we are having 1 sodium here, will give us plus. Then this one is minus. Then minus 1 times 1 chlorine, that is minus 1. So plus 1 minus 1 will cancel each other. So therefore, our products will be NaCl. NaCl. Now, we have written our products now. We have written our products. So let's assign their physical state. Let's assign their physical state. We have solid, we have liquid, we have gases, then we have aqueous. So a metal is what? will be in solid form. A metal will be in solid form. Then this is a diatomic gas, so will be in gaseous form. While this is a sodium chloride, that is salt, will be in solid form. So we have assigned their physical states. Then after that, you balance your chemical equation. I'm going to teach you the simplest method, the simplest way of balancing chemical equation. Then first identify a compound or an element with the highest number of atoms. Identify the particle. So let's say this is a particle, this is a particle, this is another particle. So identify a particle with the highest number of atoms. Identify a particle with the highest number of atoms. This one is one atom, this is two atoms, this one two atoms, but two atoms of different elements. So assign the coefficient of 1. Assign the coefficient of 1 to the what? To the particle with the highest number of atom. Assign the coefficient of 1. Raise that one up because it's not part of the what? It is not part of the compound. Now, other elements or other particle, assign an unknown what? An unknown value. So let me assign x here, then y here. So we need to look for the value of x and y. So the value of x and y will be our coefficients. Will be our coefficients. Now, at the reactant side, write all the elements that you have at the reactant side out. So at this side we have sodium, then we have chlorine. Then how many sodium at this side? That is 1. 1 times x will give me x. So there is no sodium here. Then arrow will change to equal to. Then how many sodium here is 1. So 1 times our coefficient, which is equal to 1. So chlorine. Let's come to this side. How many chlorine do we have at this side? That is 2. Chlorine is 2. 2 times y will give me 2y equal to. Then how many chlorine at this side? 1. 1 times my coefficient, that is 1. So therefore, to look for y now, y will be equal to get y, we divide both sides by 2. So y equal to half. Y equal to half. So if my y equal to half, now let's write all our unknown values out. So x equal to 1. From this side, x equal to 1. Then y equal to half. Then the known what? The known coefficient, that is the whole number equal to 1. The one with known coefficient equal to 1. Let me say 1 equal to 1. Now, this one is in fraction. This one is in fraction. You have to turn it to what? To a whole number. You turn this fraction to a whole number. So you multiply it by what you have at the denominator. That is 2 times 2. Since you have multiplied this one by 2, you have to multiply this by 2. You multiply this one by 2. So therefore, this one will give me 1 times 2 will give me 2. So 2 will cancel 2. So it will give me 1. Then this one will also be equal to 2. Now substitute the following values into your equation. My x is what? 2 now. It will now be 2Na plus my y is 1. So 1 times Cl will still give me Cl2 gas. Then equal to my 1 is what? Is now 2. So it will now be 2NaCl. So let's check if our equation is balanced now. So at this side we have 2 sodium. At this side 2 sodium. 2 times 1, that's 2 sodium. Chlorine, C times 2. Cl times 2, that is Cl2. So we have 2 atoms of chlorine. So this side we have 1 here. So 1 times 2 will give us 2. So our equation is balanced. Our equation is balanced. So let's take another one. Let's take reaction between reaction between and potassium and oxygen. Potassium and oxygen. So the first step, we assign their what? Their atomicity. So potassium is what? Is a monoatomic, but oxygen is what? Is a diatomic. So you have to put two at the base. Now we want to form our products now. We want to form our product. So we assign their what? Their valence. Their valence, that is the charges on them. So let's put charges on them. Potassium is in number what? Number 19. Potassium is in number 19. So the first shell we carry 2, the second we carry 8, the third we carry 8, then the last one we carry 1. 2 plus 8, 10. 18 plus 1, that is 19. So the last what? Electron, which is known as valence electron, is 1. So therefore the charge on potassium is plus 1, which is the same thing as plus. Then oxygen, forget about 2 at the base of oxygen. So oxygen is oxygen. Then oxygen is in number 8. Oxygen is in number 8. The first shell we carry 2, the second we carry 6. So it needs what? It needs 2 to complete what? The outermost shell, to complete its outermost shell. So therefore the charge on this one is what? 2 minus. Then after that, then you combine the charges. You combine their charges in order to neutralize each other. So this one is what? Plus 1. Plus 1 will not neutralize minus 2. So therefore I will multiply this one by 2. So plus 1 times 2 will give me plus 2. So this one is minus 1 times 1 oxygen will give me minus 2. So the charges will what? Will neutralize each other. So we cancel the charges. Then they will now combine together to give you how many K? That is 2. K2 what? K2O. So which means that when potassium reacts with oxygen gas, we give you what? Potassium oxide. Potassium oxide. So that is the product form. Then after that, we assign their what? Their physical state. Potassium is a metal, so it's in solid form. Oxygen is a diatomic gas, that is gaseous, while this one is what? Is in form of solid. So it's in form of solid now. So after this, we balance our chemical equation. So let's balance our equation now. So let's assign the coefficient of 1 with the what? With the particle with the highest number of atoms. So this one is having 3 atoms. 2 atoms of potassium plus 1 atom of oxygen. That is 3 atoms. So this one is 2. This one is 1. So we assign what? Coefficient of 1 to the what? To the particle with the highest number of atoms. So 1 here. Now, other particles we what? We assign an unknown value to other particles. So X and Y. If you like, you can use A, B. So let's continue now. Write all the elements that appear at the reactant side out. We have potassium and what? And oxygen. So only potassium and oxygen we have at the reactant side. Now, let's start with potassium. How many potassium do we have here? That's 1. So 1 times coefficient, that is equal to X. So 1 times X equal to X. So no potassium here again. So let's move to the product side. So the arrow will change to equal to. Then at the product side, how many potassium do we have? That's 2. So 2 times coefficient will give us 2. So therefore our X equal to 2. Then oxygen, at this side, we have 2 oxygen. So 2 times our coefficient, that's 2y, equal to, then how many oxygen at this side? That is 1. 1 times 1 oxygen, that is 1. So we divide both sides by 2. So y equal to half. So if x equal to 2, y equal to half, then y, then coefficient 1. So the coefficient 1 equal to 1. The coefficient 1 equal to 1. Now, x equal to 2. Then we have to make this one what? A whole number. We turn it to a whole number by multiplying it by what we have at the base. So this 2 we cancel 2. This one will give us 1. Then, since you have multiplied this one by 2, you multiply this one by 2, you multiply this by 2. So this one will now give us 4. It will give us 4. So this one will give us 1. Then why this one will give us what? 2. So let's substitute the values that we have here into into our equation. So let's substitute the value into the equation now. So our K, X is now what? Equal to 4. It will give us 4K because my X equal to K plus my oxygen, my Y equal to 1. So 1 times O2 will still give me O2. So 1 will not affect it, equal to, then my coefficient 1 is now 2 because I've multiplied by 2. It will now be 2K 2O. Now let's check if our equation is balanced now. How many potassium? 4. So how many are this side? 2 times 2 equal to 4. Then how many oxygen are this side? That is what? 2. Then how many oxygen? 2 times 1 equal to 2. So our equation is balanced. So let's move to the second stage of this reaction. So I will call the second stage of this reaction the reaction between an atom and a compound. I'll call the second stage of this chemical reaction the reaction between an atom and a compound. Reaction between an atom and a compound. So let's take a chemical reaction between calcium and HNO3. Now calcium is an atom, while HNO3 is what? Is a compound. So when you have a compound during chemical reaction to form your product, you have to split that compound. You split the compound. Then, like I said on that when I was explaining radicals, I told you that radicals cannot be splitted. You don't split radicals during chemical reaction except there is what? Evolution of gas from that radical. Now, let's split this compound into two. We have hydrogen, then NO3 is what? Is a radical, so you don't split it. That is NO3. Then you assign their what? Their charges. So calcium is in number 20. The first shell we carry 2, the second we carry 8, 8, 2. 2 plus 8, 10 plus 8, 18 plus 2, that's 20. So the valence electron is 2. So therefore the charge on it will be 2 plus. So hydrogen is in number 1. The charge on it will be plus 1. I've explained formation of charge on this radical. So the charge on NO3 is what? Is minus. So to form your product, you take positive from the first reactant particle, you react with negative from the second reactant particle. So positive here, we combine with negative here. Then the positive here is plus 2. Then the negative here is what? Minus 1. So plus 2 will not neutralize minus 1. That is plus 2 will not cancel minus 1. So I have to multiply this side by 2. So therefore you multiply what? Your NO3 by 2. So plus 2 now, minus 1 times 2 will now give me minus 2. Don't forget that this minus is from NO3, so times 2. So minus 1 times 2 will give me minus 2. The two charges will be able to neutralize each other. So they will now combine together to give you, we have one atom of calcium, that's Ca, then NO3 into base what? To substrate 2. Then plus, so we have used calcium, then we have used what? Triazonitrate 5. So we are left with what? With hydrogen. So hydrogen is what? Is a diatomic gas. So it will react in form of gas. So that is our product form. Very easy. Now let's balance our equation. Then you assign, don't forget that you assign their physical state too. Then this one is in solid, this is aqueous, this is aqueous, this is aqueous, and this one is in form of gas. So let's balance our equation. Now to balance your equation, identify the particle with the highest number of atom. Identify the particle with the highest number of atom. This one is one atom, this is a particle, this is another particle. One hydrogen plus nitrogen, that's 2, plus 3 atoms of oxygen, that is 5. So this one is having 5 atoms. Now let's look at this one. One calcium, then oxygen is 2 times 3, that is 6 oxygen, plus 1, that is 7. Then 2 times 1 nitrogen, that is 2. So 7 plus 2 will give us 9. So we have 9 atoms here. Then we have 2 atoms of hydrogen here. So this one is having the highest number of atoms. So assign what? Coefficient of 1 with the one what? With the particle with the highest number of atoms. Then other particles assign an unknown value. So I will assign X, Y, and Z to this one. Now let's start. Write all the atoms that are present at the reactant side out. So the first one is calcium, then followed by hydrogen, followed by nitrogen, followed by oxygen. So add the number of each atoms together. Add the number of each atoms together. So at this side, calcium, let's start with calcium. Calcium is 1. Then you multiply that one by your coefficient. So 1 times X will give me X. So there's no calcium here. Then my arrow will change to equal to. Then how many calcium at this side? That is 1. 1 times 1 will give me 1. So no calcium here. Then you proceed to hydrogen. How many hydrogen at this side? That is 1. So 1 times Y will give me Y. Equal to, there is no hydrogen here. Then we have hydrogen here. How many hydrogen at this side is 2? So 2 times coefficient, that is 2Z. Then to nitrogen. Nitrogen is 1. 1 times Y will give me Y. So equal to, there is nitrogen here. So how many nitrogen? Don't forget that what we have outside the bracket we multiply by what we have inside the bracket. So 2 times 1 nitrogen here, that is 2 nitrogen. So 2 nitrogen times coefficient, that is 2. That is 2. There's no nitrogen here. So let's proceed to oxygen. Oxygen. So how many oxygen? 3 oxygen here times coefficient Y. So 3 times Y will give me 3Y equal to, then how many oxygen at this side? 2 times 3, that is 6. So 6 now times 1 will give me 6. Will give me 6. So I think that's all. Then our Y equal to what? My Y equal to 2. So I can look for the value of Y from here, either here or here. So my X, let's start writing. X equal to 1 because I've gotten the value for X. Then I've gotten the value for Y. Y equal to, now our Y equal to 2. So if Y equal to 2, so we need Z. What is our Z now? So we can calculate Z from this hydrogen. We can look for the value of Z. So since Y equal to 2Z, then the value of Y equal to 2. So we say 2 equal to 2Z. So divide both sides by 2. So this one, so 2 cancel 2. So my Z equal to 1. So the value of Z equal to 1. Then the coefficient 1 still remain as what? Remain as 1. So the coefficient 1 remain as 1. So X equal to 1, Y equal to 2. So my Z equal to 1. The coefficient 1 remain 1. So we are going to substitute the following what? Unknown values into this equation. So let's substitute. So X equal to 1. So let's substitute X into this value. So X, which is 1 times Ca, will give us Ca plus my Y is now equal to 2. So you replace this Y with 2. So 2HNO3 equal to, so my coefficient 1 remains what? It remains 1. So Ca NO32, then plus, so my Z what is 1. So 1 times H2 will give me H2. So will give me H2. So let's check if our equation is balanced now. So calcium is 1 at this side. So calcium is 1 at this side. So hydrogen is 2 times 1, that's 2. So we have 2 hydrogens at this side. Then nitrogen is 2. 2 times 1 nitrogen, that is, so 2 times 1 equal to 2. So oxygen, 2 times 3 equal to 6. So 2 times 3 equal to 6. So our equation is what? Is balanced. Our equation is balanced. So that's the reaction between an atom what? And a compound. An atom and a compound. So let's take another example. Let's take another example. Reaction between sodium and hydrogen chloride. Reaction between sodium and hydrogen chloride. Then Na, let's decompose this one into 2. So we have hydrogen and what? And chlorine. Hydrogen and chlorine. Then assign their charges. What's the charge on sodium? That's plus, because it is in number 11. So that's 281. So the valence electron is 1. That's plus 1. So the charge on hydrogen is plus. The charge on chlorine is minus, because chlorine is in number what? Chlorine is in number 17. So the first shell we carry 2, the second we carry 8, while the last one we carry 7. So if chlorine carries 7, so if the last electronic shell carries 7, so it needs one more to balance. So the charge on it will be minus 1. Now, to form our product, positive will combine with negative. Then the charges must neutralize each other. So the charge on sodium is plus 1. The charge on chlorine is minus. So the positive will neutralize the negative to give us what? NaCl. So NaCl. So we have used chlorine, we have used sodium, so we are left with what? With hydrogen. So hydrogen is a diatomic gas, so it will escape in form of gas. So our product now is what? Sodium chloride plus hydrogen gas. So let's assign their physical state. Then you assign their physical state. So sodium is a metal, so it's in solid. So hydrogen chloride is in aqueous form. Then salt is what? Is in aqueous, because you have dissolved it in solution, so it will give you aqueous, then plus hydrogen gas. So then you balance your chemical equation. Let's first check if our equation is balanced. Sodium here, sodium, 1 sodium here, 1 hydrogen here, 2 hydrogen here. So the equation is not balanced. So we can check from our reactant side. Let's look at a particle with the highest number of atoms. We have 2 atoms here, that's hydrogen and chlorine. So we have 2 atoms here, sodium and chlorine. So let's use the reactant side. So assign coefficient of 1 with the reactant side. Then other particles assign an unknown value, x, y, and let me use ABC. A, B, C. So write all the elements at the reactant side out. Sodium, hydrogen, and chlorine. So at this side, how many sodium? That's 1. 1 times coefficient A, that's A, equal to, we have 1 sodium at this side. So A times B, 1 sodium, that is times B, will give us B. So let's move to hydrogen. How many hydrogen here? That is 1. 1 hydrogen. So 1 times 1 will give us 1, equal to, there is hydrogen at this side. How many hydrogen at this side? That's 2. 2 times C will give us 2C. So then chlorine. How many chlorine at this side? That's 1. 1 times 1 will give us 1, equal to, how many chlorine at this side? That is 1. 1 times B will give us B. So it shows that our B equal to what? 1. B is equal to 1. Then A equal to B. So the value of A equal to B. So therefore, A equal to 1. Then we need the value for C. Let's calculate C out. 1 equal to 2c. So divide both sides by 2. Divide by 2. Then your c equal to half. So if your c equal to half, so you have to make it what? A whole number. Then the coefficient whole number 1 still remain as 1. So to make this one a whole number, so you multiply by the denominator, multiply by 2. So you multiply this one by 2, multiply by 2, multiply by 2. So this one will give us 2. This one will give us 2. So 2 cancel 2 to give us 1. 1 times 2 will give us 2. So you can now substitute the following what? The following values into this what? Into the chemical equation. So our A is 2. So that will be 2Na. Then the coefficient 1 is now 2 plus 2HCl equal to my B is 2. So 2NaCl plus the coefficient C is equal to 1. So 1 times H2 will give me H2. So let's check if our equation is balanced. So we have two sodium at this side, 2 atoms of sodium. So 2 sodium at this side, 2 hydrogen, 2 hydrogen, 2 chlorine at this side, 2 times 1 chlorine. So that's 2 chlorine. Our equation is balanced. So let's move to the last stage of this chemical reaction. So which I call chemical reaction between two compounds. Reaction between two compounds. Reaction between two compounds. So reaction between two compounds. So let's take different examples, like reaction between sodium hydroxide and tetraoxosulfate acid. Reaction between sodium hydroxide and tetraoxosulfate acid. So what will be our products? Now let's form our products. Let's form our products. Don't forget that I explained under this under radicals that we don't separate radicals during chemical reaction and formation of products. So you don't separate radicals during chemical reaction and formation of products, except a gas is evolved from that radical. Except a gas is evolved from the radical. So OH is a radical, so you don't separate. So this one will decompose to Na and OH. Then H2SO4 will decompose to hydrogen. We have hydrogen here and this radical, which is SO4. So once the charge on sodium is plus, the charge on hydroxy ion is minus, the charge on hydrogen is plus, then the charge on SO4 is what? Is 2 minus. So you take positive here, you take negative here. Then the charges must neutralize each other. So at this side, sodium is plus 1, but SO4 is 2 minus. So minus 2 will not cancel plus 1. So we have to multiply this one by 2. So to give me plus 1 times 2 will give me plus 2. So minus 2. So plus 2 minus 2 will cancel each other. Then how many sodium? That is 2 sodium. We are going to write as Na2, then SO4. Then plus hydroxy ion will combine with what? Hydrogen ion. That is the positive minus 1 we cancel plus 1 to give us H2O. H2O. So we have formed our products. We have formed the products. So let us balance our chemical equation. Let's balance our chemical equation. Now, we are going to consider a particle with the highest number of atoms. We consider a particle with the highest number of atoms. So we have 3 atoms here. 1 sodium, 1 oxygen, 1 hydrogen. That's 3. We have 2 hydrogen here plus 1 sodium. That is 3 plus 4. That is 7. So we have 2 here. That's 2 plus 1, 4 plus 4, 7. So let's pick the one at the reactant side. So we assign a coefficient of 1 to the one with the highest number of atoms. Assign coefficient of 1 to the particle with the highest number of atoms. So other particles assign an unknown value A, B, C. So write all the elements that appear at the reactant side out. So we have sodium, we have oxygen, followed by hydrogen. So I've written hydrogen, you will not repeat it again. Then followed by sulfur, then followed by oxygen. So I've written oxygen. So add them together now. Add them together. So sodium, how many sodium at this side is 1? 1 times A, that is A. Then there's no sodium here. The arrow will change to equal to. Then how many sodium at this side? Is 2. 2 times B will give us 2B. So no sodium here. Then let's take oxygen. How many oxygen? 1. 1 times A will give us A. Then equal to, no, oxygen, then we have oxygen. There is oxygen at this side too. That is plus. Since there is plus in between, then how many oxygen at this side? That's 4. 4 times 1 will give us 4. Equal to, then how many oxygen at this side? Is 4. 4 times B will give me 4B. Plus, there's oxygen at this side too. So 1 times C will give me C. Then hydrogen, followed by hydrogen. How many hydrogen here? 1. 1 times A, that is A. Then there's hydrogen here plus, how many hydrogen here? 2. 2 times 1, that is 2, equal to, hydrogen at this side, that is 2. 2 times C will give me 2C. Will give me 2C. Then the last one is what? Is sulfur. How many sulfur at this side? Is 1. So that is 1 equal to, so at this side, how many do we have? How many sulfur do we have? So we have 1. 1 times B will give me B. So it shows that my B equal to 1. So if my B equal to 1, so what will be my A? That is 2 times 1. So A equal to 2. So let's calculate C. If my A equal to 2, so C, we can calculate C out from this place. A plus 2 equal to 2C. Then my A is now equal to 2. So that will be 2 plus 2 equal to 2C. So 2 plus 2 equal to 4 equal to 2C. So divide both sides by 2. So 2 cancel 2. So 2 here 2. So my C equal to 2. So therefore C equal to 2. So I've gotten value for A, B, C. Then the coefficients 1 remain as 1. The coefficients 1 remain as 1. So we can substitute the following values into our equation. So my A is 2. So that will be 2NaOH. 2NaOH plus the coefficient 1 remain as 1. That's H2SO4. Then equal to my B is 1. So 1 times what we have here will give us Na2SO4 plus my C is 2. So 2H2O. So let's count. So we have 2 sodium at this side. So 2 at this side. Balance. 2 oxygen here plus 4. That's 6. 4 here plus 2. 6. Then hydrogen is 2 at this side plus 2. 4. So 2 times 2, 4. Our equation is balanced. Our equation is balanced. So let me give you one more chemical reaction whereby a gas is evolved. So let's look at a chemical reaction between calcium triazocarbonate 4 and hydrochloric acid. Calcium triazocarbonate 4 and hydrochloric acid. Then what will be our product? What will be our product? Whenever an acid reacts with any triazocarbonate 4, there will be evolution of carbon 4 oxide. So that is carbon 4 oxide, which is what? CO2 will go out. It will evolve in form of gas. So which means that By the time this hydrochloric acid reacts with calcium triisocarbonate 4, a gas will be evolved. So first write that gas, CO2 gas. So a gas will be evolved. So when you remove CO2 from CO3, it will remain Ca and O. Remove carbon, remove 2 oxygen out of these 3 oxygen, remain 1 oxygen. So we are going to have CaO plus what? Plus HCl. So what will now be the product between calcium oxide and hydrochloric acid? So calcium and oxygen. So this one will decompose to hydrogen and chlorine. So what is the charge on calcium? Calcium is the number 20. The first shell we carry 2. Calcium in number 20. The first shell we carry 2. The second we carry 8. 8, 2. So the charge, the valence electron is what? Is 2. So that is 2 plus. The valence electron for oxygen is what? Is 2 minus. That of hydrogen is plus. Then that of chlorine is minus. Now, a positive will combine with negative. Positive will combine with negative. So the positive here is 2 plus. The negative here is Cl minus. So positive and negative. Then the charges must neutralize each other. So the charge on this one is plus 2. Then the charge on this one is minus 1. So minus 2 we cancel plus 2. We will have to multiply this one by 2 to give us 2 negative. So that is minus 1 times 2 now will give us minus 2. So this plus 2, then minus 2. So the charges will cancel each other to give us, they will combine together to give us CaCl2. CaCl2 plus, so we have used calcium, we have used chlorine. So we are left with what? Oxygen and hydrogen. So hydrogen is minus, oxygen is 2 minus, hydrogen is plus 1. So multiply this one by 2 will give us plus 2 minus 2. They will combine together to give you H2O, because the positive we always call before negative. So our product for this reaction between calcium triisocarbonate 4 and hydrochloric acid is calcium chloride, water, and carbon 4 oxide. Now let's balance our chemical equation. Let's balance our chemical equation. Now, assign what? Coefficient of 1 with the particle with the highest number of atoms. So this one contains the highest number of atoms. So assign what? A coefficient of 1. Then assign an unknown value with other particles. So A, B, C, D. Now, write all the elements that appears there out. So we have Ca, we have carbon, we have oxygen, we have hydrogen and chlorine. So we begin with calcium. How many calcium are this side? That's 1 times 1 will give me 1. There's no calcium here. Then arrow equal to, how many calcium here? 1. 1 times my coefficient, that's B. So followed by carbon. How many carbon are this side? 1. 1 times 1, that is 1. Equal to, how many carbon are this side? That's 1. 1 times D will give me D. Then oxygen. How many oxygen are this side? That's 3. 3 times 1 will give me 3, equal to, then there's no oxygen here. There is no oxygen here. Then we have 1 oxygen. 1 times C will give me C, plus there's oxygen here. So 2 oxygen times D will give me 2D. So hydrogen. 1 hydrogen here times A will give me A. Then equal to, there's hydrogen here. So 2 times C will give me 2C. Then followed by chlorine. How many chlorine here? That is 1. So 1 times A will give me A, equal to, then chlorine as this side, we have 2 chlorine. So 2 times B will give me 2B. Will give me 2B. Then don't forget that our B equal to 1. So B equal to 1. I've gotten the value for B. Then D equal to 1. My D equal to 1. So I've gotten value for B D. So let's look for value for C. C. So from this equation, we can calculate value for C. So 3 equal to C plus 2D. So 3 equal to C plus, my D is 1. So 2 times 1 will give me 2. So 2 times 1 is 2. Collect the like terms. My C will now be 3 minus 1, which is equal to, 3 minus 2, which is equal to 1. So my C equal to 1. So I've gotten, then the next one is A. A equal to 2C. Then A equal to, what is my C? C equal to 1. That's 2 times 1. So A equal to 2. A is equal to 2. Then the coefficient 1 remain as 1. So let's substitute these values into this equation. So my 1 remain as 1. So this one will remain as CaCO3 plus my A is now 2. So that will be 2HCl equal to, my B remains what? 1. So 1 times CaCl will give me CaCl2, then plus, then C is 1, so plus H2O, then plus my D is 1, so my D is 1, that's CO2. So let's check if our equation is balanced. So calcium is 1. Calcium is 1 at this side. Carbon is 1. Carbon is 1. Oxygen is 3. So we have 1 here plus 2. That is 3. Hydrogen is 2. 2 hydrogen. Chlorine is 2. 2 chlorine. So our equation is balanced. So we've come to the end of today's class. Remember to subscribe to Royal Learning channel and discover the joy of learning. Share this video with your friends and comment. Bye.